Hello, incredible inventors, and welcome back to Gadget Lab Adventures. Today, we're diving into one of the coolest DIY science projects you can possibly imagine. We are going to build our very own mini hovercraft, and the best part, we're going to build it using stuff you probably have lying around your house right now. Get ready to turn your kitchen table into a futuristic test track. So, what's on the materials list for this awesome experiment? It's super simple. You'll need an old CD or DVD, one you don't mind sacrificing for the sake of science, of course. Next, you'll need a balloon. Any standard party balloon will do the trick. We Lions also need a pop-top cap from a water bottle or a dish soap bottle, the kind that you can pull up and push down. And finally, you'll need some strong glue, like a hot glue gun or super glue, to hold everything together. That's it: a CD, a balloon, a pop-top cap, and some glue. For simple items to unlock the magic of physics, let's get building. First, make sure your CD is clean and dry. Now take your pop-top cap. It's crucial that the cap is in the closed position to start. We need to create a good seal. We're going to glue this cap right over the center hole of the CD. Apply a generous ring of hot glue or super glue around the base of the cap. Then press it firmly onto the shiny side of the CD, making sure it's perfectly centered over the hole. We need an airtight seal here, so don't be shy with the glue. Once it's in place, let it dry completely. This step is super important because if air can escape from the sides, our hovercraft won't hover. While our glue is drying, let's talk about the science behind what we're building. This isn't just a cool toy. It's a fantastic demonstration of some fundamental physics principles. The star of our show today is air pressure. When we inflate the balloon and release the air through the tiny hole in the cap, that escaping air doesn't just disappear, it pushes down against the table surface. And thanks to Newton's third law of motion, for every action, there is an equal and opposite reaction. The table pushes back up on that cushion of air. This upward push is what will lift our CD ever so slightly off the surface. This lift creates a thin cushion of air between the CD and the table. And what does that do? It dramatically reduces friction. Friction is the force that resists motion when two surfaces rub against each other. Normally, if you push a CD across a table, friction will slow it down and stop it very quickly. But by floating it on a layer of air, we're almost completely eliminating that friction. This is the exact same principle that real, full-sized hovercraft use to travel over water, land, and even ice. So, with this tiny device, you're becoming a real-life aerospace engineer. Okay, I think our glue is nice and dry now. Let's double-check the seal. Give the cap a gentle wiggle. It should be solid as a rock. If it moves, you might need to add a little more glue around the base and let it dry again. A perfect seal is the key to a perfect flight. Now for the moment we've all been waiting for. It's time to power up our hovercraft. Take your balloon and stretch it out a few times to make it a little easier to inflate. Now, blow it up. Try to get it to a good medium size, not so small that it runs out of air in 2 seconds, but not so big that it's about to pop. Once it's inflated, pinch the neck of the balloon tightly so no air escapes. This can be a little tricky, so take your time. With the pop-top cap still closed, carefully stretch the neck of the inflated balloon over the top of the cap. Make sure it's snug and secure. Your setup should now look like a CD with a big, colorful balloon standing proudly on top. It already looks pretty cool, right? Are you ready for liftoff? Find a smooth, flat surface. A clean kitchen table, a countertop, or a tile floor will work perfectly. Place your hovercraft down on the surface. Now for the magic moment, gently pull up the pop-top cap. Whoa, look at that! The air starts rushing out of the balloon, creating that amazing cushion of air we talked about. Give your hovercraft a tiny, gentle push. See how it glides. It's floating. It moves across the surface so smoothly, almost like an air hockey puck. It's completely frictionless, gliding effortlessly. How incredible is that? You've just built a working hovercraft. Go ahead, give it another push and watch it go. Now, this is where the real fun begins. It's time to experiment. Science isn't just about following instructions. It's about asking what if and finding the answers for yourself. So let's become scientists and start tweaking our design. First experiment. Let's play with the amount of air. What happens if you inflate the balloon to be much bigger? Try it out. Does it hover for a longer time? Does it lift higher off the surface? Now, what about if you only inflate it a little bit? You lines probably find that a bigger balloon provides a longer ride because it has more fuel, more air to release. Experiment number 2. Let's investigate the surface. We used a smooth table, but what happens if you try it on a slightly rougher surface, like a wooden floor with some texture? Or what about carpet? You'll quickly discover that the smoother the surface, the better the hovercraft works. Carpet creates way too much friction for our little air cushion to overcome. This is a great, hands-on way to understand how surface texture affects friction. For our third experiment, let's get into payload and balance. What happens if you add a little bit of weight to your hovercraft? Try taping a small coin, like a penny, to the top of the CD. Does it still hover? What if you tape the coin near the edge instead of the center? You'll notice it tilts and becomes unstable. This demonstrates the importance of a center of gravity. For a stable flight, the weight needs to be balanced. Real hovercraft engineers have to think about this all the time when designing their vehicles to carry cargo or passengers. And here's a pro tip for a longer flight. The size of the opening matters. The pop-top cap gives a good, controlled flow of air, but what if you made the hole smaller? A smaller opening would release the air more slowly, which should, in theory, make the hovercraft glide for a longer period of time, even if the lift isn't quite as strong. You could experiment with different types of caps to see what works best. This simple project is a gateway to understanding so many big ideas in science and engineering. We've seen air pressure, Newton's third law, friction, center of gravity, and fluid dynamics all in action. It just goes to show that you don't need $1 million laboratory to explore the wonders of the world around you. All you need is a little curiosity and a few household items. So I challenge you to build your own. Try different designs, different weights, different surfaces. Maybe you can have hovercraft races with your friends. Who can build the one that goes the farthest? Who can build one that can carry the most weight? The possibilities are endless. That's all the time we have for today's Gadget Lab adventure. I hope you had as much fun as I did. Building things and figuring out how they work is one of the most rewarding things you can do. Keep experimenting, stay curious, and never stop asking questions. If you built your own hovercraft, I would absolutely love to see it. Share a video or a picture with me in the comments below. And if you enjoyed this project, don't forget to hit that like button, subscribe to Gadget Lab Adventures, and ring that notification bell so you won't miss our next exciting experiment. Thanks for joining me, and I'll see you in the next video. Happy inventing!